recording as well. So yeah, good evening everyone, and hope you all of you guys are doing good. So should we start, guys? Everyone, yes or no? Right. There are a lot of things to be studied today, and it is going to be obviously fun. So let's start. So what I'm going to do, I'll start with you know using scribble ink, and then we'll start accordingly. So let's say it. I will share my screen. So, guys, to be very honest, today's topic is very interesting. At the same time, right? At the same time, very, very much, uh, tricky to understand, right? Very tricky to understand. And believe me, I have been thinking like since last week how to introduce you guys this topic, right? So this topic is really, really very, very, important and tricky to understand. I'm not saying hard because hard would be a wrong word to say, because nothing is hard. Everything is relative, how you feel, like how comfortable you are. So it's not exactly hard, but it's little bit tricky. But we are going to understand this again in detail. What is expected from you guys? Little bit of patience, right? I will be very, very patient. I will be doing whatever required. Even make sure that you guys understand everything. I will not leave you guys till then. But the only thing expected is you have to actually you know uh, be patient and try to understand everything whatever I'm going to teach, right? So that would be the only expectations. The rest just leave to me, and I will just take care of everything. So no need to worry about that. Right. So this is the just thing that I want you guys to know, and then we will start with things. So let's start, guys. Right. Let other people also join to some extent. Okay. Okay. So mhm. Then we will start. I guess we should start. Uh, mhm. Guys, I had no many people. You guys had one problem that you were not able to see the full screen. Do you guys remember that? Right. So there is a solution to it. Right. I don't know you know this or not, but I complained this to my backend team, and they got me a solution. Right. What is the solution? So I will just give you the solution. I don't know how to give you the solution. So just a second. There is a full screen option, right? I don't know how many of you know. There is a full screen option. Are you able to see this, guys, on your screen quickly? There is a full screen option, right? Right. How many of you are able to see, and how many of you are not able to see? Just click on that full screen, right? Right. Everyone did that. If you guys just do this full screen, you will be able to see everything in the complete full screen. Everyone did it? Yes or no? Quickly, guys. Right. Right. Let me see one more thing. If I just unpin myself, then in that case, what happens? Does it that I just unpin? Okay, I unpinned that. Okay, okay, I understood. If I unpin myself, then the full screen doesn't work well. But the moment I pin myself, then the full screen works well. Okay, yes or no? Right, right, right. Very good. Right. So hopefully you guys have uh, done your screen full screen, completely full screen, and now we will start with the today's class. So again, warm welcome and good evening. So let's start with today's class. So as we will start with today's class, and there are a lot of topics to be completed. So first of all, what we have completed till now, right? If I have to explain what we have completed till now, right? So how many of you guys remember what were the topics that we had seen till now? Quickly, right? What were the topics that we had seen till now? Recap, or let's say no. till now, till now, till now, right? Till now. Guys, you have to answer it quickly. Till now. What the things that we have seen till now? Quickly, guys, everyone. Right, right. So to be very honest, we started from basics of Python, right? Basics. Good evening, everyone. Good evening. So basics of Python, we started with, right? Basics of Python, right? Then we moved to operators, right? Right. Subsequently, we moved to conditionals and loops, conditional and loops. Then we move to functions, different types of functions, right? Map, reduce, filter, user defined function, right? We discussed everything, right? And after that, we also studied, that is very, very important, about recursion. This is the most important interview questions topic. Very, very important. Right. Yes, data structure, I missed it here. So we also studied about different data structure. That is completely we have discussed. But in the last class, our focus was on function and recursion. Let's say in function, we discussed map, reduce, filter, G, everything. And then we moved to recursion. And data structure was before that. Right? Everyone happy till now? We have discussed these things till now. My voice is audible, right? Everyone, yes or no? Everyone, my voice is audible? Quickly. It is fine. No echo, nothing else. Right. Very good. Right. Nice. Nice. This is the understanding. Right. Now, guys, what we are going to see in today's lecture? What are we going to see in today's lecture? Today's lecture, what are we going to look at? Today's lecture. What are we going to look at? Or agenda of today's lecture. Let's say we use the word agenda of today's lecture, right? Agenda of today's lecture. And actually, from today onwards, we can call it as, learning path of the class. What would be the learning path of the class? The first thing that we are going to study, actually, I am also confused how to teach you guys. The topics that we are going to cover is iterators. Then we are going to cover generators, right? And then we are going to cover introduction to OOPS. Introduction to OOPS. Introduction to OOPS. Object oriented programming system. And this is going to be a very, very important topic. So actually what happens in iterators and generators, there are some, right? Right. There's some syntax of OOPS to be used. That's why I was thinking to start with introduction to OOPS. But understanding OOPS is easier as compared to iterators and generators. It's not that iterators and generators are hard, but it is little bit tricky. The names are confusing. So I am also confused where to start from, to be very honest. Right. Generally, in other classes, in other batches, I start with iterators, then move to generators, and then go to introduction groups. Right. So we will start with iterators and generators only. Let's start with iterators and generators, and then slowly we will move to introduction to groups. Right. Rajkumar, those topics are, for the classes to come. After loops, we will be having exceptional handling, logging, and memory management. That is after oops, right? So we'll start with iterators, right? And at the end of the day or at the end of the class, we will also discuss about interview questions from these topics. So these are the, agenda of today's class. So we are going to discuss interview questions as well. So let's jump and start with, right, the concept of iterator. What is an iterator? Why are we going to study iterator? Right. So we are going to see everything in detail. So we will start with first iterators, and let's see now how it goes, and then we'll also discuss about generators as well. So let's start, guys. Everyone excited now? Should we start? Right. Please open your Jupyter notebook because this is very important topic. I want you guys to actually type the code parallelly, right? And then, This will make you guys understand the concept in more detail, because this is some topic that many of the people are always confused. Even they have studied twice, thrice, but they are like confused each of the time. So I want you guys to please, I request you, please open your Jupyter notebook and you have to type the code parallelly. There should not be any exception. There should not be any exception. You guys have to type the code, right? So guys, should we start? Everyone has opened the Jupyter notebook, right? Yes or no? Quickly. Very good. So that says yes. Other people? What about other people? Are you guys sleeping or what? Right. Samir says yes. Very good. Very good. So almost everyone has started, right? Everyone has, opened the Jupyter notebook. So now let's start about the iterators, generators, and everything. So let's start. So the first thing, we will start with a very small concept. What is iteration? And then we will go slowly. So let's say here we have this. So let's say I will just write here iterators, 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 generators, generators, and then introduction to that we have, right? Introduction to, right? So let's start, guys. So let's start. So what I'm going to do, I will start with a very small thing, right? Right. A very small thing. So let's say we have a list, right? So we have a list, right? So let's say L is equals to 1, 2, 3, 4, 5. So, guys, starting, I will be very slow. The reason being, I just want you guys to understand everything. But let's say L is equals to 1, 2, 3, 4, 5. So, 1, 2, 3, 4, 5. Now, guys, can we run a loop over it? Everyone, can we run a loop over it, over iterators? Can we run a loop over the iterators? Yes or no? Can we run a loop over iterators? Quickly, if you guys can answer this. Very good. Very good. Very good. So many of you people are answering yes. So what you can do here for I, for I, for I in L, for I in L, print I, print I. This is something that you do, and one by one, the elements are there. 1, 2, 3, 4, 5. My question is very simple, right? Whatever you did here, right? What is it called? Whatever you have done. So for I in L, print I. What is this mechanism called? Anyone? Just answer it. What is this called? Right, right. Very good. Many of the people are answering. Sajil has answered. Sada Praveen has answered. Very good. So you guys are saying that this is called as iteration. What is this called as? Iteration. So can I write it here? One very basic term, iteration. Guys, please be active today. Don't sit on the bed and watch the lecture. Please sit on a table, have some water, and start typing the code. This is so ultra important thing. If I have to reject someone in the interview, from Python, I will ask the questions from these concepts. So please be very active, right? How many of you have joined today's lecture? Let me see. So it is 22, right? So all the 22 students, please, be actually active and try to understand everything in detail. If not understood, just stop me and ask the question then and there, right? So let's say iteration, right? So what is iteration? For example, if I have to answer this iteration, right? How can you answer this? Right, right. How how will you define the iteration? That's a very simple question. Can I say a process, a process of taking each element or item, each item element, right, right, of a sequence one by one. Can I say this? Can I say this? This is what actually happening. You are taking elements one by one, right? Right. This is your iteration, right? This is your iteration. Very simple. But, 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 have you guys ever thought that how it is actually working at the back end? What is happening at the back end, or what is happening behind the scene that you are getting all the elements 1, 2, 3, 4, 5? What is actually happening? Right. To understand this, I will throw one more term, one more technical term over you. That term is nothing but iterators. Iterators. Right. So now I am throwing you a term called iterators. What is an iterator? So let's say I will remove as also. Iteration, you understand. A process of taking each item, element of a sequence one by one. But what is iterator? What is iterator? This is going to be more fun, right? So here I will write one thing, an object, an object. Don't get confused about this an object. What is an object, right? Because object concept we are going to study in OPS. As of now, just understand in Python everything is an object. Try to understand this. In this world, for a god, what are we? In this world, for a god, any god, let it be whatever you believe. In this world, for a god, what we are? We are just an object. That's it. Right? Right. This mobile phone is an object. Right. This notes is an object. This writing pad is an object. Everything is an object. Similarly, let's consider a world of Python, an imaginary world of Python. Everything is an object. Similarly, iterator is also an object. Now, what is the peculiarity of this object? What is the speciality of this object? Right. So it is an object that allows 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 iteration, or that allows to process or traverse through 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 a sequence sequence of data without 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 storing the entire data in the memory, without storing the entire data in the memory, without storing the entire data in memory. This is, now you must be thinking, what is this entire data in memory? Don't worry about that. I will come to this. Right. Right. So what is an iterator? An object that allows to process, traverse through a sequence of data without storing the entire data in memory. Right. This is now the thing I have written. So one thing, iterator, I will, in this class, I will keep repeating again and again, because these terms are very closely related. Many of the time people get confused. Iteration, iterator, and lost. So I'll keep repeating, right? So iteration, a process of taking each item, element of a sequence one by one. Iterator, an object that allows you to traverse through a sequence of data. Guys, now try to understand this. At one time, I am saying, what is iteration? A process of taking each item, sequencing. Now, at the same time, I am saying, what is iterator? Some object that allows to traverse through sequence of data. Don't you think, guys, there's some relation between both of them? I'm not going to say what is the relation, But don't you think there can be some relation? Yes or no? Everyone. Everyone has to answer. If no, it's okay. Just say it. No, I don't think there is a relation. I am saying, right, right. I am saying that, right, he plays some sports. I am saying he plays some sports. Here I am saying, right, right. He has a playing field. Then what is the meaning of this? There is some hint that there is a relation between them, right? Maybe he is providing the playing field, right? And he is playing sports on that. I'm not saying exactly this is happening, but here I am saying iteration, a process of taking each item one by one. And I am saying this is an object that allows to process one by one. Now, to understand this in a more better way, I will show you something. I will show you something. What I am going to show, right? So let's say here we have tuple. So t is equals to, maybe I will just write 1, 2, 3, 4, 5. Say now I am going to do for I in t, I will just print I. So for I in t, I will print I. See 1, 2, 3, 4, 5. Very good. Not a problem. Very good. Not a problem. Right. It's okay. Now I'm going to do one thing. For I in 5. See, for I in 5, now I want to print I. Right? Print I. What will happen in this case, guys? Everyone has to answer this. What will happen? Right? Right? What will happen in this case? Just answer me. Right? Right? It will give you an error. Right? It will give you an error. But the best part is what type of error? If you execute this error that you are going to get, here you will find type error. Int object is not iterable. Int object is not iterable. So till now we have seen iteration, we have seen iterator, but from where it came iterable? From where did this statement iterable came into the picture? Right now, this is again interesting, and that's where people get confused. But don't worry, I will make sure that you guys 100% understand this. Now, what is iterable? This is the question. What is a iterable? Now, this is the question. We have understood iteration. We have understood iterator. But what is iterable? Anyone? Anyone? Can anyone define what is an iterable? So let's say here, I will just write it. Iterable. What is iterable? Iterable. And guys, you can pronunciate this iterator, iterator, whatever you want to, right? It isn't that you have to say in a specific way. Many people you will see that they call it as iterator. Some people call it as iterator. So there is nothing in pronunciation, just focus on the concept. So now the question is, what is iterable? What is an iterable? Right. 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 Very good, Sajil. Sajil has answered it very correctly. Very good, Sajal. That's the best answer. Survi has also answered it very correctly. Sweet and simple. Very good. Very good. Right. So I will just write, I'm not writing the Sajal's definition. I will write a very short definition because I want to relate something. Iterable again is an object. See here. Iterable is an object, right, right, which can be iterated. Which can be iterated. Very simple. Which can be iterated. Now I will take 2-3 seconds of pause and try to make you guys understand again whatever we have seen so far. So what we have seen so far, guys, just a second, epic. What we have seen so far. So let's try to understand, recall everything. So we started with the first thing, iteration. Iteration, right? Right. We started with iteration. Then we saw iterator, right? And then we saw iterable. I will repeat 100 times, but you have to be confident here. What is the iteration? What is the definition of iteration? See here. What is the definition of iteration? We already discussed it. A process of taking each item of a sequence one by one. Meaning, what is the meaning of this? So, let's say there is a sequence, something like this. A process of accessing each element one by one is called as iteration. Everyone clear? Everyone clear this iteration? Yes or no? Very good. Now comes iterator. What is iterator? Right, right. An object that allows to travel through sequence of data. This is interesting. This is interesting. So maybe let's say this is a list. Let's say this is a list. Maybe I'm saying this is a list. Right. This is a list. Right. If it is allowing you to traverse through each of these elements, right? Element, right? Through sequence of data. Sequence of data means sequence. This is a sequence, one by one, one by one, one by one. Now this is a list, right? So let's say list is there, right? Fine. This is a list, right? Now there is an intermediate step, some intermediate step, right? Some intermediate step, right? Some intermediate step. This I'm talking about what is happening behind the loop that you learn. So there is some intermediate step, and in this intermediate step, something happens, and that thing actually allows you to iterate through every sequence. That something is called as iterator object. This will be very much clear after a few seconds, but this is the first level of understanding. Right, right, right. Then after that, what we discussed? We discussed about iterables. What is iterable? Right. That object, that object can be iterated, can be iterated. This is the three thing. Now, if I have to summarize you, then what will happen? Let's say, take example of this. T equals to 1, 2, 3, 4, 5. Right. Now, in this case, right, when you access element one by one, this process is iteration. This process is iteration. How iteration is working? This tuple is passed to somewhere, right? This tuple is passed to somewhere, which creates an iterator object, right? And whichever thing can create an iterator object, that is iterable. That is iterable, right? Right. This is called as iterable. Guys, one more thing, don't get influenced by other learners any comment in the chat, right? Because you guys are able to see each other's chat, but don't try to, don't get influenced by their, because I don't see every answer, right? Right. So maybe they are wrong and it gets stuck to your brain. No, focus on my thing, right? Just focus on my thing, right? That is more important. Okay, everyone understands that why I am saying this, right? Why? Because I'm not reading any, no, all of the specific messages that is being sent, right? Right. The reason being, sometimes learners have some other understanding. They can give you the thing, but they might be wrong as well. I'm not pointing out to someone. It is just that I just wanted to make sure that you guys understand this. Okay. Okay. Now, now, right. So again, I will go to my notes so that you guys can have the nodes also ready parallelly. So we have this nodes that we have to see here. So first thing, iteration. First thing was iteration. Iteration means very simple. If you are printing 1, 2, 3, 4, 5 sequentially, this is your iteration. Sequentially accessing. Very good. Sequentially accessing. Now this 1, 2, 3, 4, 5, right, 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 is sequentially accessed. How? 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 It is actually converted to an object that is called as iterator. Object, this is called as iterator. This actually allows you to iterate over this object. Iteration, iterator. And whichever object is able to create this iterator object, this is called as iterable, 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 iterable. Whichever allows to create iterator object, this is called as iterable. Whichever allows to iterate through, that is called as iterator. Iteration means accessing element one by one. Is it clear now, everyone? Yes or no? Right? Yes or no, guys? This should be very, very much clear, right? Everyone, right, right, right. Crystal clear, guys. This I have been preparing since 4 5 months. I was like, whenever I will start my own batch, then how will I make them understand, right? And if you are not able to understand, guys, just let me know so that I will make sure that you understand this. Is it clear, everyone? Right. Generally, I take also one analogy. What is one analogy? Right. To understand this. So let's say this is your, you know, what to say, right? Rajkumar says, please repeat once, sir. Okay, Rajkumar. Very easy. What is iteration? Iteration means sequentially if you are accessing the element one by one. So let's say this is a tuple. T is equals to 1, 2, 3, 4, 5. You are able to access the element that is called as iteration. Very good. Not a problem. Now, whenever there is a tuple, right, you make it something, right, in some other format so that you can do iteration or you can iterate over it. That is called as iterator. And if something is flexible enough to become an iterator, that is called as iterable. Analogy, very simple. Analogy, analogy, very easy. Yes, Sajil, you know, I guess. Potato analogy or vegetable analogy. Very simple, very easy, right? Right. So let's say there is a vegetable, let's say vegetable box, right? Right. Potato, tomato, tomato, right? Something like this. Or let's say potato one. There is one type of potato. There is potato two, potato two. There is potato three, potato three. Very easy. There are three potatoes. Now, guys, does it happen? You go and eat potato? Just went any to a supermarket, just bought the potato and started eating like this. Yeah, potato, potato, and started eating like this. Does it happen so? Right. Does it happen so? Everyone, yes or no? Right. It never happens. No. Then what you will do, guys? So let's say there is vegetable, right? What you do? So let's say there is a vegetable, potato one, potato two, potato three. Let's say now this vegetable, right, actually gives you the flexibility to be cooked. So you can just write can be cooked, can be cooked. So there is a format, there is a form where you have to bring this potato to be cooked. What is the form? Maybe you will wash, Maybe you will take out the upper layer, take out or spill. I guess spill is the word. I don't know. Take out upper layer of the potato. Take out upper layer of potato right? Then maybe you will make it in pieces, right? Why are you able to do so? Why you are able to do so? Because potato has this property to allow you guys to do these things. If assume there is a stone, can you do so? Will you be able to cut the stone to cook? The answer is no, right? So can be cooked. How can you cook? By bringing this potato in a stage where you have washed, take out the upper layer of potato, cut into pieces. And if you are able to do so, this is called as cookable, cookable item, right? Right. This is ready to be cooked, ready to be cooked, ready to be cooked. Now, this ready to be cooked is nothing but iterator cookable. It means you can process this to make it ready. That's why it is cookable. This is called as iterable. That's it. Is it now clear or is it still not? You guys are able to relate it. Is it clear, everyone? Yes or no? Quickly, right? Right? Everyone, right? 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 Is it clear, everyone? Right? So far, so good. Right? 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 Very good. Right? Very good. Right? 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 Uh, Sajil is asking, what is asking? Iteration cooking hoga na. Iteration cooking hoga na. You can think anyway, right? But just remember any one analogy, right? Right. Each time you can just have different analogy to understand, right? But this is the way you can simply understand. That's it, right? Now, moving ahead. So we have understood this. So far, so good. Right, 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 right. Now moving ahead. So we have understood about iterator. We have understood about iterable. We have understood about the iteration. Now the question is, why are we studying this? Why iteration? Why are we studying iteration? Why iteration? So this is iterable, fine. Now the question is, why iteration? Why are we actually studying this? This is the question now. Why iteration? Okay. Why iteration? Right. Why iteration? Right. This is very interesting. Right. This is going to be very interesting because, so for example, if you want to, right, if you want to see or iterate over a stream, what you will do for I in career craft? Let's say career craft, career craft. So what you will do? You will print I. So something like this, right? CAREER craft, something like this. Very good, not a problem. Still, the question is same. What? Why you need iteration? First, accessing the elements that we have seen. Second, so I'll just write accessing the elements, accessing the elements. But this is fine. Accessing the element is fine. Second thing is very, very important to do some computation. To do some computation. To do some computation. If you want to do some computation, right, then you need to iterate through. For example, I will give you a very simple example. Let's say there is a list of element, right? So let's say for I in range of let's say maybe 100, right? Already you guys know the range function. We have discussed it earlier as well in loops. If you guys remember, yes or no, everyone? Quickly. Everyone say it quickly. Yes or no? Right. Very good. So for I in range 100. Now what I want? Let's say here I want I. Right. For I in range of 100, I want I. So now let's say here we have all the numbers. See, 0, 1, 2 till 99. See, very good. That's not a problem. Now the question is, so let's say this is a number. So number, this is your number. Very good, not a problem. This is a number. Now, this number, you want to actually add some constant value to each of this number or multiply some constant value to each of the number. Maybe you will square the number. Maybe you will do cube of the number. Anything that you want to do. Let's say. Right. So let's say here, what I am going to do for each of this number, for I in number, right? I want to do what? I want to simply print I plus 10. I'm just doing this. So what will happen, guys? See, the value that started from 0 now has become 10, 11, 12, 13, 14, 15, something like this. Right. So the second thing is to do some computation. While writing the code, it is possible that many times you will do this type of computation. But fine, understood, not a problem. Iteration, we have seen this. We know from the loops. What is the new thing here? Okay, okay. There is a new thing. What is the new thing? Right, right, right. And why are we studying this now? Iteration was fine. Why iterator? Why? Right? Iterable. Why? Why it is needed? So to understand this, I will again come back to this example. So number is equals to, for I in range 100, whatever number is there. So this is your list. So this, if you see type of number, this is your list. Very. This is a list. Right. Now, let's say this is 100. Now I will do very big number. See, it is taking a little bit of time, right? It is taking a little bit of time. Still, it is list. So everyone is happy that this is a list. Very good. Now I want to see the size of the list. Right. I want to see the size of list. To see the size of a list. So what I will do? To see the size of a list, what I will do? So there is a module, right, in Python that is called as sys module. So import sys. And sys module has a function sys dot get. So here I will just write sys dot get item size. There should be a function get item size. So let's say get, not item size, let us get size of. So get size of. So this is your get size. Now what I'm going to do, I will pass this list now. I'm doing nothing. So I will just again remove this. Right. Now what I'm going to do, to see the size of list, I have passed this. So first of all, I will start with this. So see guys what happened. So this is your 8856 bytes. So this is in bytes of memory has been used by this list. Now let's say I will increase this number. How many bytes is there? 8000 has been changed to something 85,000. Again increase the number. See? It will take some time, but it will give you the size of this list. Okay, it is taking a lot of time, but hopefully we will be able to see that. Come on, come on, come on, come on, come on, come on. Okay, it is taking too much of time. Right, it is taking too much of time. So what I will do, I will just remove this, stop this, and just show you. Sorry guys, I executed a big number. Okay. Now, if you see it again, This is this size. Again, if you increase 10 or 20, again the size will increase. So what is happening here? What is the insight out of this? What is the understanding? Understanding so far. Understanding so far. Understanding so far. In the list, in the list, the element size increases, the memory increases. Yes or no? Everyone, quickly, this you understood? Yes or no, guys? Quickly, right? Quickly, guys, yes or no? Right. This is the first understanding, right? Right. Very good. Not a problem. You have understood this. Now, what I am going to do? This is very interesting. Now here I will copy the same code. See, I will copy the same code. I'm not doing anything. I will copy the same code. And now what I'm going to do? Oh my God. So I will copy the same code. So just, yeah. I will copy the same code. Increases elements. So I will copy the same code. And here in this case, range of again the same value. But this time I am storing it like this. X is equals to this. What is the meaning of this? So see here. This is something range. I will talk about this in detail. And now I will start using like this. X equals to this. Now I am going to do for I in X. For I in X. I will put the same number of zeros so that I can relate, I can compare to make you guys understand, right? So I will now, what I'm going to do, I will just use this. I will just use this and the same thing. Okay. So now for I in X, for I in X, right? Again, I am doing print I plus 10. I am doing the same thing. See, for range this, I plus 10. I am doing the same thing. It will take some time to execute. It has been executed. Same thing, same way. Only difference was I loaded in a form of a list and then I did a loop that we had done this here just a few seconds before. Something like this, right? I'll just copy this so that everything is together, right? And now again, I tried changing some logic and this time I'm using for I in X print I plus 10. Now, again, I will copy this, right? Get size of number. But this time, I am using one more thing. What? So this time, I will just put, okay, this is a very big number. This is a very big number. So I'll just, comment this. So let's say comment. So I'll just comment this, right? But this time what I'm going to do, I will just write here instead of num x and see what happens. So this is 48 bytes. This is this number of bytes. In fact, you increase the number or decrease the number. Let's say I decreased. What is the size? 48 bytes. Again, increase a big number. Big, big, big. Right? Again, it is a 48. Don't you think, guys, this is surprising? Right? You are able to do the same thing. You are able to add the number. Again, here also you are able to add the number. You saw I showed you. But the moment I showed you the size, sys.get size of x, here it is only 48 bytes. Here it is, I don't know how many bytes it is. Right, right, right. Now you must be wondering, how's that? Right, 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 right. So to understand this, right, to understand this, how it happened, right? We will go again back to the same thing. Iterators, iterables, that's it. right? It simply means, it simply means this range is actually an iterator. Because if you remember, while defining iterator, I had written one very, very important thing that you guys missed it. An object that allows to process traverse through a sequence of data without storing the entire data in memory. And this is your this is your iterator. So I can simply write the size of x is very low. Even even you increase the value of range number. The reason being it's an iterator. It's an iterator. And what is the iterator definition? Already we have seen the iterator definition. That is the most important thing, that without storing the entire data. So each time it is just storing one element. That's the understanding. So did you guys understood a very simple thing, that why are we studying this iterator or this related concept? Because to understand that sometimes it will be very hard to load the complete data in one go, and that's where you will use this uh, you know tricks to actually use iterators or iterable to understand this. Right. Obviously, I will come to this at a later part of the class, but this is the understanding. Right. Right. Tushar says it reduces computational time. Yes, Tushar, it reduces the computational time. The reason being very simple. Reason being very simple, because it actually takes the data one by one. Right. Right. I will show you. I will show you. But this is the understanding. So you guys have understood why iteration, why we need to understand iterator and associated concepts. Associated concepts. Now, this is clear, everyone. So far, everyone is clear. Good with the pace. Anyone has any doubt? Right? Everyone? Right? Right. List is an iterable. I will come to that. So now I will come to that. I will come to that. Don't get confused. List is an iterable which actually creates the iterator object. And I will show you how to know this. Don't worry, I am there. First of all, till now, is it clear, everyone? Satya Prakash says, why 48 till now? I am confused. Satya Prakash, my elder brother, very simple. If you eat all the food at one time, your weight will be 100 kg. If you eat every hour little bit of food, your weight will not improve in one go. That's the same logic. So I will explain it again. Very easy, right? So let's say there is food item 1, food item 2, food item 3, food item 4, food item 5. If you eat everything in one go, if your weight is 60 kg, it will increase to 62 kg. But what will happen if you want to taste all the food? Let's say F1 on Monday, then you go for washroom and all, get your stomach free. Next day you eat F2 on Tuesday. Next day Wednesday F3, Thursday F4, Friday F5. Still, if you measure your weight after Monday, so let's say Monday you measured it was 60 kg, most probably after fifth day your weight will be also, let's say, 60.2 kg or something like that. So in earlier case, in traditional approach, the list of the value was actually calculated in one go. But in this case, here you see the value will not be calculated in one go. It will come as you demand more and more. How? I will show you. But this is the understanding that at one point of time it is just accessing one element, and that's why you see a very small chunk of the bytes. Is it clear? Right. Right. Okay. Should I move ahead? Everyone is clear? Right. Right. Very good. Very good. Now, you must be thinking, Ajay, that is completely fine. I understood. Right. 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 But but how come? How come? How come this iterator thing will come, or how to know? Right. How to figure it out that something can be iterated through or not? Let's try to understand this. So let's say we have L is equals to L is equals to L is equals to very simple 1, 2, 3, 4, 5. So L is equals to 1, 2, 3, 4, 5. Now if you see type of L, right? What did you get? It is a list. Very good. Not a problem. Now what I'm going to do? Right. Right. So let's say now I will use a keyword iter. See what I'm doing. This is iter. What is this? Iter. Iter. The moment you write iter and just write L, right? Right. So let's say these are different type of potatoes, right? Different type of potatoes. The moment you say iter L, iter will check if these all potatoes are cookable or not. If it is cookable, then it will give you a list iterator object, right? Potatoes. Very good. Different type of potatoes. Different type of potatoes. Potatoes. Now, eater eater checks if these potatoes, potatoes are cookable. Very good. And get it ready. Get it ready. So now it is ready. Now, fine. And if you have to print the type, you can just print it also. So iter L, just do type of this. So the moment you do type of this, you will get this is a list iterator. Not a problem. Now the point is, let's say this is ready to be cooked. Ready to be cooked means to iterate through. But how will you iterate it? So to iterate it, what you can do? Iter L, I will just write N. N means number. Let's say I will just store this. You can just see N is this. Now what you can do? Next of N. The moment you write next of N, you will start seeing this 1. Again write next of N. You will find 2. Next of n, you will find 2. Again, do next of n, you will find 3. And this is the reason what is happening. Each time you need the number, each time you need the number, then Python goes back, checks out what could be the possible next number, then gives to the number 1, 2, 3, something like that. And that's why this is the reason that the memory that you saw is only 42 bytes as compared to this, because in one go all of the elements was computed, but here one by one as you need it. Just do again next of n 4, do again next of n 5. After that, I guess elements were only 5 in number. It will give you an error, that is stop iteration. It means what we did next time, next time, next time, we did iteration. We did iteration, and The moment elements ended, that's why it gave you stop iteration. This is the understanding. So again, I will just write it something here. Very easy. Right. So here analogy was vegetable is potato 1, potato 2, potato 3. Right. Now you check it. Can be cooked or not? How will you check it? You will wash it, take out the upper layer of potato, cut into pieces. So it is ready to be cooked. This becomes iterator. So the moment you write L equals to 1, 2, 3, 4, 5, you don't know that it can be iterated through or not. You don't know. Right. The moment you do iter L, and it creates an object. It creates an object. Then you say it that it is ready to be cooked. So this has become iterator. This has become iterator. Right. Right. Ready to be cooked. Right. If it would not have been made ready to be cooked, I will show you how there is a problem with it. If it is not ready to be cooked, then it is not iterable. That's checked. So now this iterator is created. It means this particular list is iterable. This is iterable. So this iterator object, this object, if it is created, that is iterator. It means if an list is able to create iterator, it means it is iterable. That's it. Right? Right. Is it clear, everyone? Yes or no? Yes or no, everyone? So far, so good. Quickly, yes or no? Santanu, can we fetch any particular mentioned number? No. Right. Everyone is clear so far? Quickly, yes or no? Everyone. Right, 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 right. Now, guys, right now, now. Sushant says what we have nested list. Just do iter and check it out. Right. Just do iter and check it out. Right. Shantanu, yaar, potatoes are list element or list itself. What I mentioned here, there can be multiple elements that you can say potato one, potato three, potato five, anything. Right. Right. That's it. Right. So the list will be potato, right? If you are able to cut it, chop it, then you can say that it is iterator. It means ready to be cooked, right? That's it. Right. Now, anyway, now moving onwards. So this is the understanding. This you got stop iteration. Fine. Now, all of your questions will answered. You will find it very easy to understand now, because the main problem is to understand it, we have to do a lot of things to understand this. So let's say here A is equals to 5, or let's say A is equals to first career craft, career. Now see it, guys. You know A is equals to career, yes or no? Right. Now, if the moment you do iter, what will happen, everyone? The moment you do iter, what will happen? Right. It will create an object. So this is your string object. If it is able to create the string object, it is means, what does it mean? That it means this is an iterable, yes or no? It means this is an iterable. This is a iterator object. If you are getting an iterator object, it means this is a iterable. Simple. Now what are you going to do? So this is your iter A. Maybe let's say s is equals to this. Now keep doing this. Next of s, this becomes your iteration. Next of s, next of s, next of s, next of s. This becomes your iteration. Next of s, and finally, when the elements will be over, this will be stop iteration. Again, I will take you an example. Let's say this time b is equals to tuple 1, 2, 3, 4. Right. To call it iterable or not, what you will do? First, do iter. If an object is created, let's say b, if an object is created, see, iterator object is created. What is iterator object? It allows to be iterated. So now you know that this iterator object has been created, it means this is iterable. Now do the iteration. How will you do the iteration? See here. C is equals to something like this. Now what you will do? Next of C. Keep doing. Next of C. 1. Next of C. 2. Next of C. 3. Next of C. 4. Next of C. Stop iteration. Again, I will repeat. So B equals to 1, 2, 3, 4. To call it, if it is iterable or not, very simple. You have to do iter of B. If it is able to create an object, then you say that this is an iterable item. You are able to create an iterator object. Now do the iteration next of C, next of C, next of C, next of C, and you got it. Stop iteration. Right. Now let's see another example. Let's say D is equals to 5. Now, can we do iterator of D? Right. Yes or no, guys, everyone? Yes or no? By the same logic that we have seen till now. So what will happen now? Iterator of D, int object is not iterable. It means iterator object, it was not able to create. Python was not able to create iterator object for this integer. Now, if it is not able to create the iterator object of this integer, it means it is not iterable. Right, right. This is the understanding. Right, right. So I will say that unless we create iterator object of tuple or career graph, we cannot iterate. Yes, right. That's the thing happening at the back end. You don't know. You don't see this. For I in career craft, you don't know this, right? But at the back end, the same thing is happening. First, it is made as iterable object, then you iterate through. Otherwise, you want to see this, see it, you will find the same error. See, for I in 5, see, same error. You see this error? Both of the error is same. It simply means at the back end, iter and next, iter and next, iter and next happens. Iter actually happens once, next, each time happens. And that's why you are able to see 1, 2, 3, 4, 5 or whatever value is in there in the string. Clear? Everyone? Yes or no? This should be very, very clear. Right? Yes or no, guys? Yes or no? Everyone. Sahil says, can we use iter rather than for? What is the meaning of this? Can we use iter than for? Right. For is a loop. Iter means iterated creation of the object. Right. Right. Everyone, is it clear? Yes or no, guys? Quickly. Everyone, yes or no? Quickly. Right. 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 Very good. Very good. Now, guys, I'm going to provide you some very, very good pointers. How to figure it out. Right. Right. How to figure it out. Right. Right. How to figure it out. Which is an iterator. Right. Guys, for next 10-20 minutes, no questions. Let's focus on this. Okay. How to figure it out. Right. 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 That something is iterator or iterable. How to figure it out things. Right. So first thing, this is very important. Pointers. Pointers. Very important. Right. You might have seen that this iterator, whichever is iterator, you were using iter and next. So can I write one comment? Very simple comment. Every iterable, see here, right? Or let's say every iterator, because we created an object. So every iterator has both iter function, iter and let's say both iter and next function. Anyone has any question on this? Guys, now you can ask. Anyone has any question on this statement? Every iterator has both iter and next function. Any question here? Quickly, guys. Every iterator has both iterator and next function. Any questions here? Yes or no? Quickly. Right? Everyone, guys, please, everyone. Everyone. Okay. Fine. Fine. Right. Right. Now, this is the first comment. Now, the next comment, right? Every iterable, right? Every iterable, every iterable, every iterable has iter function, has iter function. Every iterator, if it is already iterator, it means which allows you to iterate over, then it will be having iter and next function. Right. Now, you don't know if an iterable has next or not. You might not be knowing that if it is there or not. So that's why I mean if every iterable has iter function. Whichever can be iterated will have iter function. That is the meaning of this statement. Now, this is going to be very big statement because this is many times people are confused about this. So let's see this as well. Every iterator, every iterator, right, 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 right. Every iterator, whichever has iterator object, every iterator or every iterator object is also iterable. Also iterable. Very easy. Every iterator object is also iterable. Right. And last thing, very important. Right. Right. Every iterables may or may not be iterators. Now, guys, this is, I know, very confusing, all four statements. But if you want to understand in depth, you have to, you know, have some patience and understand that. That's it. Right. I will prove these comments one by one, how to figure it out, if something is iterable, if something is iterator. I will talk about everything. But these are the four statements. See it carefully. See it carefully. What is the statements? Every iterator has both iter and next function. Already you have seen this. If this is a iterator object, you are able to use iter and next function. Every iterable has iter function. Obviously, if something is iterable, then you should have iter function. Every iterator is also iterable because if you have created an iterator object, then only it is iterable. That's why the third statement. And the fourth statement, every iterable may or may not be iterators. So vice versa, a third statement might not be true. This is the fourth one. Now, how to prove this? How to understand this? Right, right. Very easy. So let's say here you have a is equals to some number. Let's say 10. We have a is equals to 10. Right? Now, this is your a. Just do, right, directory of a. The moment you do directory of a, what is the meaning of this? Dir of a. It means all the object method associated with this a will be shown. Let us see this. So here if you see, you get a lot of things. Absolute, add, and, bool, cell. See here, a lot of things are there. See here, invert, lay, shift, mill, new, any method, whichever is associated with numbers, you will find this. But answer me a very simple thing. Do you see here any method named as iter or any method named as next? Are you seeing this quickly? Are you seeing this? Are you seeing this? Right? Right? Everyone? No? So let's say now I will show you another value. So A is equals to this time some list 1, 2, 3, 4. Now see this time this, and now do directory of A, dir of A. See here. Do you see something here? So let's say add class here. Okay, get item, very good, add in it. Oh my god, there is a function called iter. This is iter here. Are you able to see this? Yes or no? Right, right, right. So here it is iter. But do you see here next? Are you able to see next here? Are you able to see the next here? List is, so here again, come back to these four comments, right? Every iterable may or may not be iterators. Okay, first thing. Every iterator has both iter and next function. This is the first point. Every iterable has iter function. This is the second point. So what I'm going to do, I will copy this first. So it is very clear. So first point already we have discussed. Every iterable has iter function. Example here, this was not iterable. You know this. That's why you didn't saw iter function. Here you know list is iterable. That's why you see the iter function here. Iter, where is iter? Iter function, right? There was iter function. Yes, here is iter function. Yes or no? Let's see any tuple. So let's say A is equals to 1, 2, 3, 4. 1, 2, 3, 4. You already know that this is iterable. So now, can you see dir of A? What you will see? See here, you will find iter function. See here, iter function. But still, there is no next function. So it proves this statement here that every iterable has iter function. First point clear. Has every iterable has iter function. Quickly, guys. Everyone has to answer this quickly. Yes or no? Is it clear? Right. Very good. Very good. Now moving ahead. So now the second statement is every iterator has both iter and next function. So now how to make something as an iterator? Anyone? So let's say here A is equals to 1, 2, 3, 4, 5. How to make an iterator object out of it? How to make iterator object out of it? How to make a iterator object out of it? Quickly, guys. You have to guys answer it. Right? Right. 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 I will just show you for dictionary as well so that you know that there is again the iter statement, iter method, right? Right. So now, how to make iterator of this tuple, right? How to make iterator of this tuple, right? So here, how can we make this? Very simple. Just do iter. So the moment you do, it becomes a iterator object. So this is your tuple iterator. Now comes the interesting part. So let's store this in a variable a, let's say b, or let's say tuple is the t. T is equals to iter of a. Now do dir of t. You will be surprised to see, since it is an iterator, you will find next also, right? Right. There should be iter as well, and here iter as well. So now it is again proved that the iter object has both iter and next. The iterator object has both iter and next. I will just write iterator object has both iter and next. And that's why it again proves that if you are iterating through a loop, then first iterator object is created, then we use the loop, sorry, next to iterate. Is it clear, everyone? So far, so good. Yes or no? Did you guys understood this? Second pointer. Everyone, quickly. Say it quickly, guys. Everyone, yes or no? Right? Everyone. Now, third point. Let's say third pointer. Every iterator is also iterable. This is obviously true that every iterator is also iterable. Once you have iterator object, you can just iterate through. And every iterables may or may not be, iterators. So many of the time you will find, that few iterables, you might not have the iterator object. So you don't need to worry about this fourth pointer, but focus on this three pointer. So this is all about to know, right, 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 how to figure it out, which is iterator, which is iterator object, what is iterable, what is the iteration, everything. Is it clear now, everyone? Now you guys have some confidence that you guys have understood this concept of iterator, object, iter, and something like that. Little bit, yes or no? Is it crystal clear? Quickly, guys, because now we will jump to some problem statement. We will have some fun with the problem statement as well, right? Is it clear, everyone? बताइए, everyone. Right, right. Very good, very good, very good. Oh, other people, let me say it. Uh, Adeline, sorry, uh, Ada, did you understood? Adeline, did you understood? Is it clear? Adeline and Ada, right? Is it clear, everyone? Yes, I'm not understanding. There are only 24 participants. The enrollment is 125, right? Where the other people are? Do I need to call them? Oh, Ada says following. Adeline says yes, sir. Very good, very good. Right. So here we have, Salil is saying code again. Praveen says, can we iterate over integer value of 1, 2, 3, 4? Praveen, please try it out. You have to answer this question. Right. Now, guys, obviously, Praveen, you cannot iterate it because integer is integer. It is 1 or 2, or it is 1, 2, 3, 4. It doesn't matter. Integer. You cannot iterate for it. Right. So let's see it. So b is equals to 1, 2, 3, 4, and just write for I in b. Here I will just write print I. Right, right. See, int object is not active. Right, right. That's it. Right, right. Nalata says, can you explain with example of fourth pointer? See, fourth pointer, don't worry about that, because here what happens, sometimes there are some data structure, right, right, which doesn't have iterator object. That's why it is, I'm just skipping this. You can just remove this pointer as well, but don't worry about this pointer. Okay, right. Right. So sometimes what happens, some iterables may or may not have the iterator, right? They may not have some iterator object, and that's why I have written this statement, right? If you want me to prove it, then I have to just figure it out. But yeah, don't worry about that, right? Right. Should I move ahead, guys? Everyone, right? So far, so good, right? Right. 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 Oh. Anyone has any questions? Quickly, guys. Very good. So now, guys, let's say you know that you know uh, how loop works now, right? So loop is nothing, right? Right, 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 right. Loop is nothing but iter and next, right? Mhm. Okay, so this I can just explain you. So every iterable may or not be iterator. Just simple list, example list. See here, this is the same example. Right, same example list. See what happens, I was thinking in some other way, but anyway, every iterable may or may not be iterator. Very simple example list. So for example, in list, right, right, here list is an iterable, right? Until and unless you use iter, until and unless or until you use iter, it is not an iterator object. It's not an iterator object. That's it. Very simple, and done. That's it. Right. This is the understanding of this. I was thinking that can I have some data structure where I can prove it, but obviously there are limited data structure and whatever we have seen already we have, right? So it's simple here. If you use iter, then only this is an iterator. Otherwise, in its native form, it is not an iterator. Everyone agrees to this. List in its native form is not an iterator. The moment you use iter, then only it becomes iterator. Got it, everyone? Yes or no? Very simple example, right? I just thought let's make it clear because due to one pointer, I cannot skip that. Okay. Now, guys, moving ahead. Very good, we have understood. But again, one more point. To know something, right? To know something, to know something, to know something, to know something. If to know something, if it is iterable, what you can do? If it is iterable, if it is iterable, what you can do, guys? To know something, if it is iterable, what you can do? Everyone, to know something, if it is an iterable, what you can do? First, directly use for loop. Second, use dir. That's it. Use dir. You will get to know if it is iterable or not. That's it. Done. This is the conclusion so far. Now I am going to show what I'm going to show. I want to make a loop on our own. Can we make a loop on our own? Can we try doing so, everyone? Now you know how loop works. Can we make our loop and see that how it works with using iter and next? Everyone, quickly. Can we do so? Anyone wants to try it out? Just try it out, guys. If you guys want to try it out, otherwise I am there. Right. So let's say maybe Sada says custom iterator. Yes, Sada. Very good. Right. Sada already is expert in Python because seeing his comment, I have figured it out. Is it Sada? Have you already studied Python in detail? Now, let's move ahead. Right. So this is your use for loop. Now, this is going to be very interesting. Can we make our custom loop? Right. Can we make our custom loop? Right. So let's say I will just write here custom loop. Right. Custom loop. Custom loop. How to make a custom loop? Right. 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 So now, how to make a custom? Very easy. So I'll write few pieces of code. Don't worry about this because there are few things that has not been taught to you. Right. Right. So let me just write the code and then I will discuss. While true. Right. While true. What is the meaning of while true? I will come to that. So now I will just write try. This is try and then I will just put except, 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 right. And then here try, except, and then now what I can do in try, I will just write, let's say there is a string. So maybe s is equals to iter of s. So s is equals to iter of s and then item is equals to next of s, next of s. And each time, then what you will do? You will just print this item. First, iter, make it an iterator object, then do next, and then finally, here, we'll just print item. Print item. So print item. Very easy. Print item. Now accept what I want in accept. So there was an error. Where is an error? That error, type error, stop iteration. Accept stop iteration. So accept a stop iteration, right? If stop iteration comes, then what I will do? Just break it. So what I will do? Just break it. So I will just do break, break. What is the meaning of this? try, accept, stop iteration. You don't need to worry about that. Consider this as a magic as of now. You must be thinking, as a teacher, how can I say this? Just understand that this is some magic. This, this you know actually, but let's say this is a magic. This is a magic. That's it. Just consider as of now. Main thing, what I am doing, as equals to iter of s, item is next of s, done. Now just define as is equals to career craft. Career craft. See here, career craft one by one. I'm not using any loop. Same thing I could have done like this for I in s print I. See here, same thing I could have done like this way as well, right? Oh, for I in s. What is happening here? Career craft. Okay, as is actually redefined, so I have to just put it as here. So as is equals to career craft. Again, I have to redefine as here. So now it will work easily. So here as is equals to this. Now career craft. Guys, see, I am doing a live coding. You should also understand wherever I am missing something, you need to note it down. Why the teacher missed this thing? Because this will come with you as well. See here, very easy. It was a very classical mistake. Here I had an as equals to career craft. Here also I had named the same variable. The moment it came out of this, and it was looking at as, and as is now iterator, then it was not able to iterate through, and that's why here the career craft was there. So it was not iterator, but iterator object here, iter of s. And then again, the problem was I was trying to loop in that case, and that's why it was not coming anything. It was not printing anything. But anyway, this is the understanding. So this is how actually loop works. That's the complete understanding. Is it clear? Everyone, so far so good. Yes or no, guys? Quickly. Right, 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 right. Very good. Very good. Now, guys, last thing in iterator, and then we will move ahead, right? With something else, and because this is very, very important, right? Very, very important. So, what I'm going to do, what I'm going to do. So, this is your career craft. Uh, you can also put this inside a function. I don't, uh, you know, have a problem. You can just put inside a function. But last thing that is very, very important, right? This is going to be a lot of fun. So let's say here we had as equals to, let's say, career craft. Very good. Now this is a very, very confusing point, you can say, very tricky point, but very important. Let's say here you did an iter. Iter of what? This is your s. So you can just say object of this iterator. Very good. Object of this, right? Fine, there's no any problem. Object, see, very good. Not a problem. Right, right. Not a problem. Now, someone might come and say, this is your object. Fine. This is your object one. Fine. Object one is this. Now I am again trying. So let's say here print object one. I will just do this. Now what I'm going to do, I'm going to again use iter of this object one. I'm again going to use this iter of object one. So in this case, what will happen? Right. So let's say this is your object two. Object two. Object 2 is equals to this, and then print object 2. Print object 2. What will happen in this case? See here. What are you going to see here, guys? What are you seeing here? Right, 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 right. What are you seeing, guys? Anyone? How can you explain this? Just try to think it. What is the meaning of this? To more clarify, what I can do, print ID of object 1. What is the storage of this? Print ID of object 1. Object 1. And here also I will do print ID of object 2. Object 2. What you are guys seeing here? Quickly. Right. Very good story. Very good. So if you take iterator of again iterator, then it will actually return the same thing. Right. If you make a new iterator out of already iterator, out of, or if you make a new iterator of already iterator object, an iterator object, then, then, then you will refer to the same memory location or to the same iterator. That's it. Slash memory reference. This is the point that you guys should know about this. Mhm. Clear, yeah? Here, till here. Quickly, yes or no? Yes or no? Quickly. But now, guys, question. Now we have understood what is iteration, iterator, everything. Now, guys, you should relax because there is no any confusing thing. So let's take 2 minutes of break and just discuss, just casually talk. Guys, did you have you guys understood this? Whatever we have seen till now, 100% of this. Everyone, yes or no? Right. 100% of this. I want you guys, right? Everyone to understand this 100%. Right. 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 Okay, just give me a second. Okay. साजिद से लास्ट वाला थोड़ा कम समझ में आया बहुत इजी है यार आपने what you have done it's very easy to understand very easy that you have made a iter object right again if you want to make iter of this again already made iter object then both will be the same thing that's it right? That's it. This is the understanding. That's it. So guys, let's take maybe uh, 5 minutes of break and then we will restart. Is it okay, guys? Everyone? Mm-hmm. Right. 5 minutes timer. Should we start, guys, everyone? Yes or no? Quickly. Right, right. Very good. Very good. Guys, so let's start again. Let's start again. Uh, poo, 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 poo. So, guys, should I end iterators here or should I raise the bar? What do you say, guys? Is it like you are happy with the iterators till now, or you want to play with it more? Tushar says raise the bar. Okay. Okay, so let's start. We will raise the bar. Everyone is excited. So let's make our own iterable object. Right. Right. So what is the use case? What is the use of understanding iterator? Many of you were asking, right? What is the use case of understanding iterator? Make our own iterator object class. Make our own iterator object. So let's start this. Guys, one disclaimer. What happens in life sometimes, what happens? So whenever you uh, uh, live your life, right? Right. Sometimes what happens, right? That suppose that you are, uh, what to say? You are dating someone. Let's say, imagine. Suddenly, right, one day he or she will stop replying you, right? You will not understand anything, right? Right. You will surprised and you will keep thinking about that particular incident, why that particular person is not replying you for days, and you will waste your time. Right. Right. So what is the learning from this story? Anyone? Whatever I mentioned, what is the learning from this story? Can you answer this? What is the learning from this story? Okay, no one is able to answer. Mhm. Betrayal. Anyone else? Learning is very simple. Learning is very simple, right? If you don't understand few things, just ignore. Don't waste time by thinking about it. This is the simple understanding. Don't waste your time. So the thing that I'm going to explain is actually not at this level, should not be taught at this level. This should be only taught after uh, oops concept is completed. So don't worry about that. Right, right. If you are not understanding, just have fun. What I am going to do, just see it. Okay. So now let's make a custom iterator object. Right, right. Or iterator class. So let's see how can you make it. So let's say if you want to, right, square a number between a given range, right? You want to square a number between a given range. So what I will do, I will just make a class square a number, or let's say square range. I am making a class. What is class? Don't worry, I will come back to this advanced thing again after oops. I will make you understand this again, so don't worry. Right, why I am explaining you now here? Because in case I forget at that point of time, you can refer to that, refer to this. So square range. So now, right, I will just make a pass. So this is our iterator. So let's say, sorry, iterable. So this is our iterable, which will call actually our iterator, which will call our iterator. So this time, what I will do, class square iterator, square iterator, square iterator, iterator. So this is our class. Very good. Right. Now, what happens in iterable? So iterable calls the iterator. So what I will do now? So let's say here, I will make a init method. What is init method? A very simple function. This is called as a magic method, but a constructor as well. Just consider that this is a function. So here I will use self. What is self? Don't worry. Don't worry about self. I am just writing start and end of the number. Very simple. And then I am going to say self dot start is equals to start. Don't worry about this. We will come again to this, right? So self dot start equals to start, self dot end equals to end. So I have assigned this variable of start and end. Now what I will going to do, I will just call a iterator method. So def iterator. So I'll just do iter, right? Def iter, def iter. So I'll make a iter method, and iter method I will just write self. What does iter method do? It calls the next method. So here, how will I call the next method? Next method I will put here inside square iterator. So I'm just copying this. So return square iterator, and here I will just pass the self, so that I can access all the variable out of this self. Very easy, right? I know you don't understand this, but it's okay. See what I'm going to do it, because this will again come back. It will come back again. So now what I'm going to do, so def again init method of this class. In this init method, what I'm going to do, I will just take the iterable object. So iterable object, I will just take this iterable object. Very good. So def init of iterable object. Now, in this init, we have to also write a self method. Done. So this is your iterable object. Now what I'm going to do, self dot iterable is equals to iterable object. So we have now the iterable object which you will use to do next iteration. Now after that, self dot current is equals to, right, self dot current. What is the current variable? So maybe I will just write iterable object dot start. So we have start. Very good. Now after that, what I can do, def again make a iter method which does nothing but, let's say, take self, right, and return self. So return self. Let's see. Now, this is the second method inside this square iterator. So here we have done iterable. Now we are doing iterator. Now this is iterator method. Maybe now what I'm going to do is next, because iter is done. Now we are going to do the next method. So how to do the next? This is the last method for this. So next, and here I will just pass self. I will just pass the self. And now, since you want the square number between two range. So you don't want the first starting range to be greater than the ending range. So in this case, what you can do, you can just use a if self dot current. So self dot current is greater than equals to self dot iterable dot end. Very simple. Iterable dot end. You have to raise stop iteration. Stop iteration. So if while iterating, if your current value becomes greater than the end value, it means you have to stop the iteration. The next has been done. You don't need to do any next thing. Now, after that, what you have to do? Just do the square of the number. So square is equals to each time the current number, self dot current. Self dot current, you have to do the square number, asterisk asterisk square. Very good. Now then, after that, you have to just increase the counter of current, because you want another number each time. So current is equals to plus equals to 1. You can just write anyway whatever you want. So plus equals to 1, or self dot current plus 1. You can do the same thing. And then finally, you have to do return square. Now, I know this is little bit tough. I did a quick now writing, but let's say now what I'm going to do, I will just call this square range. So this square range, first of all, let me call this square range from 1 to 5. So I called this from 1 to 5. This is your iterable object. So let's see it. Very good. This is an iterable object has been made. So I will just write square iterable, and this becomes your square iterable. Then what I can do, for num in square iterable, for num in square iterable, just do print num, and rest is done. So now see here, from 1 to 5. So 5 will be excluding. So 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. In this way, you have created your own custom iterator class. So we have created our own iterator class, or let's say iterable class, right, for squaring the number. Custom class for squaring the number. So guys, I'm not going to ask how many of you are having doubts, because I know everyone would be having some doubts. Right, right. But see, this is not something I'm expecting you to understand. Just understand that using this iter and next, we can make any object that can be iterated. Right. Very simple. In fact, we can also make our own range function. Own range function. So if you want me to code that as well, I can code that as well. So you can also make a range function. Right, right, right. So what I will do, I had a code that I had got ready right before the class. Mhm. Just a second. I'll send you that code that you guys can see it at little stage as well. So where is that code? I had kept it somewhere. Just a second. Just a second, guys. I had kept that code. I will send you that code as well. So this code, you can just see on range function. So here you can just use this. Now, what are we going to do this? So here, if you want to, so what I have done, I will explain you. But if I want to just call it, so here I can just write my range. So let's say here, this is your my range. This my range function. You can just put 1 to 5. So this is, let's say, the value 1 to 5. So this is your iterator object. Now what I can do, so object here is this. Now for I in object, for I in object, I in object, print I, print. Very easy. See, 1, 2, 3, 4. So what I have done again, here yeah, I have init method, lower limit, upper limit. In this lower limit and upper limit, what I'm going to do, I'm going to call my range iterator. What does my range iterator do? Iter and next. That's it. And each time just increase the value by 1. So this is how I can just simple make our own custom iterators, whatever you want to do. This is a template. This is a template. Just change the template and you can copy paste. Obviously, you will not be having the complete understanding of this, but I will come back again to this topic so that it is clear for you guys. Okay. Should I move ahead, guys? Yes or no? Right? Yes or no, everyone? Should I move ahead now? I know this is like you must be thinking I have not understood this, but yes, don't worry about that because I will come back again to this particular thing. Should I move ahead, everyone? Right? Quickly. Right? Very good. Very good. So now, guys, one thing you might have seen to make an iterator object. So here, let's see. To make an iterator object, right? You had to code a lot. You had to code a lot. You had to code a lot. So you have written a lot of code. See here. It's a very big code just to write a range 1, 2, 3, 4. Right, right, right. Then how we can, right, right, write not so big code and still get the same thing? That's the question now. How can we do so? So again, Python is very helpful to the users like us. Right, right, right. So they did something, right? What they did, they came up with another function called generator function. This is interesting. They come up with generator function. What is the meaning of this? Right. What is generator function? Right. We will discuss everything because this is again going to be very, very important. Because we have to also understand, right, right, using this, right, what is the use case of iterators? Iterators we have understood. We know few things. But what is exactly use of iterators? We will be able to understand once we understand generator. Then I will make you solve a lot of problem statements. A lot of problem statements. Right. So let's start with this. Let's start with this. The first thing, right? To make a custom iterator object, right? You had to code a lot. Very good. Then came generator. Generator. What is generator? Right. What is generator? Generator. Generator is. What is generator? Generator is application of iterator. Iterator. Very simple. Application of iterator. Right. So what is generator? So generator is, if you have to define formally, generator, generator is a function. Generator is a function. Generator is a function, right? Right. When called, gives generator object, generator object. Very simple. It has yield, yield instead of yield instead of return. Now I will just show you. Don't worry. Instead of return. So I'll show you what is generator. Right. So I'll just write now a new topic, that is generator. Now guys, so let's try to understand this one by one. Right. So I will define a function because generator is a function. So let's say define generate numbers. Very good. This is a function. Now inside this, I will write yield. Y-I-E-L-D. Yield. 1. Y-I-E-L-D. 2. Y-I-E-L-D. 3. Y-I-E-L-D. 4. Very good. Done. Generate number is done. Now this generate number, if you want to see, let's see it. This is your generate number. Now just execute this. What do you think? What is this, guys? See it. What is this? Everyone. What is this? Right. 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 What is this, everyone? An object. Generator object. Right. Very good. This is a generator object. Generator object. Now what you have to do? Just use next of this. So if you do next of this, you will get 1. Again do next of this, you will get, okay, it is not giving me the numbers. Maybe what I will do, generate numbers, because it is called 1 by 1. So I will just make a something like this. So generate numbers, I will just copy this. So generate numbers, and this is your generate numbers object. So maybe I will just write gen of this. Now, fine, this is gen of this. Now I am going to do next of gen. Now see what happens. 1. Now I will again copy this next of gen. See what happens. 2. See again what happens. 3. Now see what happens. 4. Now see what happens. See what happens. Next of gen. See what happens. What will happen next? Stop iteration. The thing that you were doing using a lot of code, now you will be able to do in a very easy way using yield statement. So again, I will repeat. What is a generator? Generator is nothing but simple way of executing iterator. Very simple. Simple way of executing iterator. This is the first. Sweet, simple. That's it. What is generator? Is a function when called gives generator object. So I showed you that whenever I called it, it gave me generator object, right? It has yield instead of return. So here if you see, there is no any return statement. It has only yield statement. Now you must be thinking, what is the difference between yield and return? But anyway, can anyone just explain me what is actually difference between yield and return? Anyone has any idea? You have to answer me, guys. What do you think? Everything is in front of you. Yield statement is there. You already have seen that how to use a return statement. What is the difference between yield and return? Quickly, everyone. Let me see how many of you can answer this. In front of you have everything in front of you. Right? Survey says yield means generate or produce. Very good survey. That's a very valid point. But return gives means give. Wow, this is a very good thing. So that also says a very good thing. But I think uh, Survey has given a very good answer. Yield means generate or produce. Very good. I will just write it. But actually, this is not the complete understanding. I will come to the complete understanding. Yield means generate or produce. Generate or produce. Very good. This is actually a part of our notes now. And return means give. Very good. Return means give. Now, it is actually good for analogy. But what is the meaning of this? What is the difference between return and yield? This is the question. Difference between return and yield. Now, this is the question. How to make you guys understand? Don't worry. I will make you guys understand in a very easy way. So let's try to understand this. Before understanding, right? What observation you might have seen? The observation is that when I was using next of gen, it gave me 1. Whenever I used next of gen, it gave 2. Similar to iterator, it is just giving the value from next onward. It is not going back and creating the number from 1. To make it more clear, what I am going to do, I will go to Python tutor. Python tutor. And, and I will copy this code. Right. I will copy this code. Right. So I'll copy this code. I have copied this code. Very good. And now what I'm going to do, right? What I'm going to do, we'll just copy this main function as well. So I have copied this main function as well. This is going to be very interesting, right? You'll be surprised to see few things. Visualize the execution. So now I have to visualize the execution. Very good. Here you don't see anything, frames, object, nothing, right? So this is a function. Go to next. What will happen, guys, here? What is happening? So here we have a global function name that is generate numbers, and function is gen numbers. Very good. Now, next. Next is, this is very interesting. See what happened. There, here it is, generator instance. This is the instance of generator. Very good. Again, next. Ideally, what should happen, guys? See here. Generator instance. This generate number. Once this function is called, then this generator instance. Now, here it has gone to generator numbers again. So again, next. See, yield 1. Very good. Now, again, see next. This is interesting. If you use a normal function, it will return one value and come out of the function. Everyone agrees to this? If you use a normal function, right, it will return a value and come out of the function. So here yield one has been given. Do the next. What will happen? It will come to next generation again. And see, one has been removed as of now. You are not seeing one again, right? And this time, now, the moment you keep doing next, it will not execute it again. It remembers that, okay, last time I had executed one. To make you understand it more, what I will do. So next gen, I will copy this. Next gen. So here I will copy this like this. So print next gen. So make you understand this very beautiful. It's very interesting thing. If you guys understand this, right, generator concept will be very crystal clear. Very crystal clear. So now I will show you the magic. So now I will just copy this and again paste it here. Read this code. Right. Now see what will happen. Right. Go back. Very good. Frame object, nothing. Generate number. This function is called. Very good. Right. What will happen? It should ideally go inside this function, but it didn't went inside the function. It came to directly next gen. What will happen now? See next gen, it will go here. Then what will happen next? It should go yield one. It will give you yield one. See return value is one. Now again move ahead. It came to the second one. This will give you the again yield one, but it is not printing yield one. See, it is not printing yield one because this generator knows that this particular line has been already executed. So this time, if you just execute this, now this will give you 2. And that's the best part. This you have to understand it. In normal function, once returned, it comes out of the function. First thing. Second thing, if you see here, the moment I was executing, it didn't executed yield 1 first. If it would have been executed yield 1, you would have got printed something first, that is 1, then 2, right? But it is not happening so because generator function remembers what has been executed in the last time and then it continues from there. Did you guys understood this? Very important, right? Right. This is very important, right? This is very important. I repeat it again. This is very important. Very simple, very simple. Whatever has been executed with the help of yield, it will not be re-executed. Tushar says means generator is going to memory one for what is going to print it and what. Yes, you can think it in that way to understand things. Right. This is what exactly is happening. Everyone, is it clear? Yes or no? You keep in printing the next something like this. Always it will go to only yield 2, yield 3, not print the previous one. See, this time came to yield 2 and next line is yield 3. It will see that, okay, yield 3 is there, print yield 3, not yield 1 and yield 2. Is it clear, everyone? Yes or no? Quickly. Right. Right. Everyone has to answer this. What is the meaning? What is the difference between both of them? Yes or no? Right. Right. Using Python tutor. Using Python tutor, we understood understood that the generator function actually right remembers the last executed line, right? That's why that's why it's not re-executed again. That's the understanding. Right. 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 Is it clear, everyone? Yes or no? Right. Right. Yes or no? Right. The same thing, whatever you have done here, print next, next, next. You can do the same thing like this as well. So let's say generator. This is your generator object. You can just write for I in gen print I. You can do this as well. Print I. Very simple. You can do same thing. Obviously, this generator object has been uh, you have to write it like this. Most probably this would work. But let's say you can just try to do this as well. So generated numbers 1, 2, 3, 4. You can do the same thing, right? So I can just okay, anyway leave it. So this is the understanding. Is it clear, everyone? Yes or no? Everyone has to answer this yes or no. Is it clear? Quickly, guys, because now I am going to show you more applications of generator object, but it should be clear. See, basics should be very clear, right? Right. So now, let's say a regular function. You want to make a regular function. So this is a regular function for squaring a number, for squaring a number, for squaring a number. What you can do? Def square number, square numbers. So how can you square the number? Very simple. And let's say here n is there. So result is equals to something like this. The result is equals to like this. So what I can do for I in range of n. So this is a normal function. This is how you write the function result n, then maybe result dot append, and here maybe let's say you will just write I square. So this is your I square, and then finally what you will do, return result. This is a normal function, return result. Very good, not a problem. You will return the result. It's not a problem. Now square number. You want to square the number, let's say 5 till 5. So I will just write here square number till 5. Right. So what will happen is square number 5. See here. Oh, result spelling is wrong. So result. So fine. So result, here it is. Now square the number result 5. You get this value. Very good. Not a problem. Easy peasy. Right. But the moment you use a bigger number, it will start taking a lot of computation time and space. Right. Okay. This was very low, I guess. I have to give a bigger number. So it will take some time. See, it will take some time, right? It will take some time. Obviously, you understand why, right? Right, right. So that's a problematic thing. So if you increase the size by a big number, the the computation time, obviously will be big, and also the space taken or the memory taken will be high. The memory taken will be high. This is the problem. This is the problem. Now, what is the solution? See here, I will do nothing. I will make a square generator function. How? See, the square number generators. So here, I will just change the number first. The square numbers generator. So that obviously I can distinguish between both the function. And what I am going to do for I in range of n, I am not using anything, nothing. See, for I in range of n, I will yield. What I will yield? Yield I square. Very simple. Now, the square number generator, each time you call it, right? Each time you call it. So let's say square number generator. So here I will just write square number generator of 5. So this is your generator object. So this is your generator object, square number generator at this memory location. So now this is your generator object. So gen, and then please do next of gen, and see here. Keep doing it. Next of gen. Now again copy paste it. Control C, Control V. Again 1. Again 1 square is 1. Obviously 2 square is 4. Keep doing it. There will be no any problem of time and space complexity. Something like that. There will be no any problem of space. Did you guys understood this? Applications. These are the applications. Right. If you want to know the number, how we can do this, again, you have to keep actually repeatedly execute this. Then only you can do that. Because Python has a limitation. If you guys remember, I had shown you guys that limitation in integer. What could be the highest number of value that can Python store? Do you guys remember that? We had discussed that in integer, right? In the data uh, native data type, native data structure. We had discussed that. But yes, each time you have to re-execute next, and then only you can get to the number. Another example, guys, Fibonacci series, right? Fibonacci series, right? Fibonacci series. Why will you calculate everything, right? Everything and store somewhere? Just calculate whenever needed, right? Again, so def Fibonacci, right? Fibonacci, and this time again, what you can do? Use yield generator. Very easy. So this is a corner case. A equals to 0, B is equals to 0. Done. Now for I in range. So you already know for I in range and let's say here I can just write yield A. And already we have discussed this logic. A comma B is equals to A plus B. A plus B, and here it will be B. Done. This is the logic. Now what you can do? So you want Fibonacci of any big number. Fibonacci of any big number. If you go with a normal calculation, it will give you an error. It will take a lot of time. But now f is equals to this. Now do very easy thing. Next of f. Keep doing as many number of times you want. So each time only one computation will happen. Each time only one computation will happen, and it will not throw any error. I guess there is some problem with it. So I have done for I in range n, yield a comma b, b a plus b. Okay, b equals to 1. Sorry guys, this I have done the mistake. So now if you see next of f, 2, next of f, 3, and next of f, 4, and so on. That's it. This is the application of generator function, right? This is the application of generator function. Right. Everyone, so far so good. Yes or no? Yes or no, guys? Quickly. Right, right. Yes or no, everyone? Now, guys, this was a lot of things that we have seen. But now the question is, we have also actually understood what is the working of generator. Very good. We have understood everything. Right, right. We saw the working of generator. So I will just write it here so that if you guys just want to remember why this is a big number, I did the right. Hmm. Difference and working of yield. We already have discussed this. Now the question is, fine, we understood iterators, completely fine. Then we understood generators to actually make things easier from the natural iterator or the traditional iterator. But why are we studying iterators and generators? That's the question. Right? Why iterators? Why generators? What is the reason? How in the industry it is used? Right, right. So first of all, I will give you few things. Right, I'll write some pointers. Right, with the benefits and everything. So don't worry about that. So first of all, industry use case. Industry use case of iterators. We'll understand this. Right. Obviously, you know that right, generators is there only to minimize the effort to create iterators. Generator is nothing without the application of iterators, right? So you understand that. So first of all, let's try to understand the industry use case of iterators, right? So what is the industry use case of iterators, guys? Anyone has any idea? So you have seen the working. Just imagine how would you use iterators? Just think it, right? Right? Think it, guys. Should I give you a situation? And actually, this question I had asked in an interview. Everyone will try it out, right? So let's say I will ask you this question. Very easy, right? So let's say you have a laptop or you have a machine, right? Right, of 4 GB RAM, right? Right, right. You have a data set, right? Which you have to manipulate row by row, manipulate row wise, right? This data set can be anything, image data set, tabular data, doesn't matter. It can be anything, right? But the space that this data set is taking is around 20 GB. How will you read this image or how will you read this data and manipulate the data? That's the question. You have to answer this. How do you? How will you do this? Quickly. Let's see. Quickly, guys, everyone. Rajkumar says, very good. Using generator. Okay. So what will happen, guys? So I'll write a code. Right. So let's say you are reading a file. I will write the code in front of you and you see that what I am going to do. I'm going to do nothing big, very easy. So what I am going to do? Very simple. So let's say you want to read a data, right? So let's say you want to read the data. So let's say here, def, see here. I'm not using any data as of now. We will see in deep learning. Don't worry about that. Read data, right? Right. Now what I will do, right? Very easy, right? So let's say I'm going to read data and this data is having the some file path or folder path. In the folder, you have a lot of images. Let's say you have a lot of images. Then now what you can do? You can simply say that whatever folder or whatever image is there. So for file in this path, obviously this will not be the exact code. So for file in this file path, what I am going to do, I will read this. So read. So how you read? So you use OpenCV library, and you can use that to read the data. As of now, don't worry about that. But the point is, you just read the data, right? Read the data, right? And this read. So if an image is there, it can be converted to an array. So you have read the data. So let's say data one or data simple data one, and then you can just say yield my array. So one by one, this path will be read and it will give you an array. So let's say base GB, 20 GB, 20 GB of the data is there. You don't need to read all the data in one go. If you will read all the data in one go, your system will crash. Your system will crash. Instead of that, you will just use yield or a generator function one by one to actually read the data and check out the data, do whatever computation you want to do. That is the use case, which we will be seeing at a later stage in deep learning and all. So industry use case of iterators, very easy reading the image data or any big data, image slash big data one by one by one. That's it. This is the first thing to avoid loading loading in a memory, loading in a memory at once. This is the industry use case that you are going to use. Now, after generators, what is the benefit of generators? Benefit of generators. It is very easy to use, right? Easy implementation, easy implementation of iterators, right? Implementation of iterators. This is the first thing. Very good. Satyaprakash is saying less code. This is the first thing that you need to understand. Second, it is memory efficient. I have already proved here in this case as well. Iterators are memory efficient. Generators are also memory efficient. Memory efficient. I have showed you lot of times this efficient. So this is a your memory efficient. This is the second thing, right? Right. Now the second thing, third thing. There was one term that was used by Sada few minutes before. I don't know how many of you remember that, but he had used one term called lazy evaluation. So this is very, very important statement. If you want to learn big data or PySpark, this you will know at later stage, but lazy evaluation. What is the meaning of this lazy evaluation? Right? This means that the values that the values are generated on the fly. On the fly simply means whenever needed and only when required. That's it. And only when required. Only when required. And that's why it is very, very helpful. Right? It is very, very helpful. This is the understanding. One more thing, multiple, you know, uh, Lexi evaluation or lazy evaluation. Multiple generators can be used, right? Multiple generators, that is also called as chaining generators. Chaining generators. I can give you an example of chaining generators. It's very easy. So chaining generators, you can use multiple generators in one go. Very easily you can use multiple generators. So here we had Fibonacci number. So I'll just copy this Fibonacci number. Let's say this is your Fibonacci number, right? So this is your Fibonacci number. So Fibonacci number, yield A, right? Now, what I'm going to do, so I will just write a square number. Let's say def square. So here I will just write a square and this time again num. So now what I'm going to do, see it carefully. For num in, right? Or for an in, let's say an in num. Very easy. For an in num, ild, 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 and square. What I'm going to do, I will explain you. Don't worry about that. So this is the thing I am doing. Now what I will do? So I am going to do one thing. First, Fibonacci of number, fib of 10, or let's say fib of 5, whatever I want to write. So fib of 10, right? After that, what I'm going to do, I am going to pass each of this number in square. Very easy. Let's try to look at this. See here, first generator object, very good. Then after that, this Fibonacci is there, then square is there. Now what I'm going to do, just do sum of this so that you can see the value. So sum of this, so this is the value that you are getting. Right? Right. Something like that. Right. So what happened? I have used, so what I'm going to do, so used two generators together. You can do this as well together. This as well. Now you want to see the value. Obviously, you know how to see this value. Just you can just write maybe for I in or I in. Just try it out. So square Fibonacci of number. So let's say square of Fibonacci in number. You can just write print I. So most probably we will get the number something like this. 0 square is 0, 1 square is 1, 1 square is 1, 2 square is 4, 3 square is 9, 5 square is 25. And if you see, all of these are Fibonacci number and then squared. So generating Fibonacci number, generating Fibonacci number, Fibonacci number, Fibonacci number, and then squaring it. So this is also one of the benefit, right? And again, on the fly, you can get the numbers. This is also one of the benefits. Is it clear, everyone? Yes or no? Everyone. Memory efficient, already we have talked about that, right? We have already seen this thing. So this was all about iterators, generators. Now we are going to move ahead with the new concept, that is OOPS, object oriented programming system. So guys, should we take some break and then we will again restart introduction to OOPS. So we will start with the introduction to OOPS and then we will, have some basic understanding. Then we can end today's class. So let's take 5 minutes of break and then we will again restart. Okay. So just I will take a 5 minutes of break. Should we start, guys, everyone? Yes or no? Very good. So, guys, now comes the very, very interesting concept that actually makes Python a Python programming language. Python is so famous, you know. Why Python is so famous? If someone asks you, what would be your answer? Obviously, ease of use is one point. But OOPS, object oriented programming system, this no, the this pedagogy of writing a code is actually very big concept, right? See, to be very honest, without OOPS, without OOPS, no any project can be done. No any project can be completed. If I am saying, sorry, if I am saying with so much confidence, then you must be thinking about that, right? You must think about that. Why OOPS has become so important. One of the hardest concept, right, in Python is OOPS. One of the hardest concept. But yes, if you understand this, you will be right at the top of your game, right? You will be at the top of your game, right? And this is going to be fun. Obviously, this is going to be fun. So let's say OOPS. What is OOPS? Right. So this is defined as object oriented programming. This is the first thing. What is OOPS? Object oriented programming. As per system, you can just remove this, but many of the time people like this, or otherwise don't remove this. I have been saying this n number of times that anything in Python is an object. Right? I have been saying this. Anything in Python is object. But how? Right? I didn't showed you enough example. Can we make our own object? Right. I showed you today a little bit by creating our own uh, generator, sorry, iterator. But obviously, the question is, can we also create our own object? Object is easy, but can we also create our own class? So we have to understand everything. Why OOPS is needed, how OOPS is used, and believe me, this is something a little bit on a tougher side, a tougher concept. But if you understand, your life is fun. You will enjoy this. You will enjoy this. To start with OOPS, I will show you a few things. So let's say, right, let's say I will write A is equals to 3. See, A is equals to 3. And then I will show you type of A, type of A with a print statement. So what do you see, guys? This, if you just write this, what will you see? You are writing integer, and this is class. Have you ever thought what is this class? Okay. Or another example. Let's say B is equals to career craft. Career craft. Right. If you see print type of B, type of B, what do you find, guys? See here, class string. Very good. Again, let's say I will do instead of B, instead of B, now I'm going to write C. So let's say C is equals to career craft. Right. Now what will happen in this case? See, again, this is a string. Now instead of A equals to 3, I will write B is equals to 5. Right. B is equals to 5. B is equals to 5. Right. B is equals to 5. Right. B is equals to 5. You will see again, this is integer. Now, the problem is why there is integer here, why there is integer here as well, why it is that B variable is also a string, T variable is also a string, and everything is the class. What is the meaning of this? What is this class? I will give you another example. A lot of example I can give you. So for example, let's say S is equals to career grant. Career. Let's say career. Now you want to append something as dot append. Right. So let's say you want to append a list. Right. 1, 2. See here what will happen. A string object has no attribute append. Again, what is this object? Right. 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 This was class. Very good. This is object. What is this object? Right. This is actually related to the concept called OOPS, Object Oriented Programming System. And OOPS has, if I have to say OOPS, if I have to write it here, OOPS, right? OOPS, OOPS. If I have to write OOPS, it has few important division that we have to understand in very detail. You can say that these are OOPS principles. What are these OOPS principles that we are going to study in this class and the next class? First, what is a class? What is the object? What is polymorphism? Right, right, right. What is encapsulation? Encapsulation, right. What is inheritance? Inheritance, right. What is abstraction? Abstraction. All of these things we are going to study in OOPS. Right. Today, we will try to understand these two things, right? And in tomorrow's class, we will see how much we are going to cover, right? These are the things we are going to see in OOPS. And one more thing, OOPS is an important concept, and the Python project that I have made for you guys will be based on all the concept, obviously, but you have to do OOPS programming there, right? So already Python project is ready for with me. The moment, the day I complete exceptional handling and logging, I will start with the Python project, right? Right. So class and object, today we are going to complete it. So very, very important. So let's try to understand this one by one. To understand this, I will start with some analogy, right? So analogy one, right? Right. So let's say you want to study at a university. You want to study at a university. You want to study at a university. Right. So let's say Satya is there, Rajkumar is there. Right. Rajkumar is there. Right. Now Tushar is there. Does it happen, guys, that Satya comes at the university? He asks about the form. Give me an application form. I will fill the form. Application. Give me an application. I will apply and I will get the admission. Does university say to Satya, okay, take this admission form? And Satya goes happily. But the moment Rajkumar goes, university says that, hey Rajkumar, there was only one application form that we have already given to Satya. So we cannot take your application. Does it happen so? Does it happen so, guys? Everyone? Does it happen so? Quickly, yes or no? Right, right. The answer is no. It will not happen. If Tushar will go, university will also not say the same. That okay, we have given the application to Satya and Rajkumar, please go back. No. Then what will university do? University will have template or also called as blueprint. University will have a blueprint. Right. What will be this blueprint? What will be this blueprint? Very easy. what will be this blueprint? Right. So in this blueprint, maybe something like this: name you are applying, right? Right. Course for which you are applying, age, date of birth. Let's say this is a blueprint. This will be given to everyone. Satya, Rajkumar, Tushar, any A, B, C, D, E, everyone. So consider this blueprint as a class. This is your class. This is your class. This blueprint is your class. So now you have some blueprint. This is your blueprint. Blueprint. With what? Let's say name, age, course you are applying for. Now this blueprint, if it goes to Tushar, this becomes object of Tushar. So this is your class. This, if Tushar fills it, name, Tushar, age, let's make him very old, 90 years, course, maybe DSA, right? Now again this goes to, let's say Rajkumar. So let's say name, Raj, age, let's say 56, class, AI, right? Tushar is saying building design. Okay. So this becomes another object. Then again it goes to Sada. It goes to someone else. And so on. So this becomes class. This is your blueprint. Blueprint is nothing but class. As it goes to individual, this becomes object 1. This becomes object 2. This becomes object 3. This becomes object 4. Simple. Simple. Right. Very easy. So this is your class. This is your object. This was analogy 1. Let's try to understand more. Analogy 2. Analogy 2. Right. Right. So let's say there is car 1, car 2, car 3. If I ask you, go and sit in that car. I am standing here and I am asking you, go and sit in that car. I'm not saying anything, not pointing out even. I'm not pointing out. I'm just saying, go and sit in the car. Go and sit in the car. Now, all the doors are open. Which car will you go and sit? Go and sit in the car. Which car will you open and sit? Right? Everyone, if I say go and sit in the car, which car will you go and sit? Rajkumar says anyone. Other people, you might also get confused. You will say, I don't have any idea. So can I say you are confused because the person has not told you go and sit in the car, or let's say go and sit in the red car. If someone will say go and sit in the red car, then obviously you will go and sit in the red car. So can I say car is again having, let's say car is having, let's say 4 wheels, right? 4 tires or whatever it is. This is your blueprint, and car 1, car 2 and car 3. This is your object 1, object 2, object 3. These are different objects. Yes or no? Everyone. Can I say like car is a blueprint? What is the blueprint of a car? This should be the height, this should be the tire, this should be the mileage, something like that. Right? Again, Car is the class. Now different colors. Car 1, car 2, car 3 is an object. Yes or no? Everyone, yes or no, guys? Quickly. Everyone, guys, yes or no? Right. Right. Similarly, let's say this was your class car. Another example. I will show you this example. I already have told you this. Right. So A is equals to 1, 2, 3, 4. 1, 2, 3. So the moment you print type of A, right? Type of A. What is this? Print type of A. Print type of A. What it will become? This is class. The moment you change the value again, it still will be class 1 to 5. Let's say it will still be a class. Why? You can consider it as list is a class. It is a class, but different list, different values of list is object. Is object. This is the understanding. Different values of the list is object. That's the understanding. So class is a list. Values when defined object. So list, tuples, right? All are class. But when you define it, that becomes an object. So can I write it now? The definition of a class? Class is nothing. Class is a blueprint. Blueprint. And every class will have will have attributes and method. Now, what is attributes and what is method? We will discuss in tomorrow's class. But as of now, you have little bit idea about what is a class. Let's go to interview questions directly. So these were the very important things that we have discussed today. Interview questions, believe me, if I have to reject someone, then I will ask very simple questions. What are iterators? And a lot of time people will get confused, though people will not be able to answer this, and then I will just reject them. That's it. Then after that, iterations. Then what are generators? Generators, very important. Use case of generators. Difference between yield, right? Difference between yield and return statement. Very, very important. Return statement. What are advantages of iterators? Very important question. Advantage of iterators and generators both. Iterators, iterators, and generators. But very good. So these are few interview questions that can be asked. Rajkumar is saying, can you elaborate object once? Very good. Very simple. Uh, just try to understand this. Rajkumar. Can I say I am a human? Yes or no, Rajkumar? Quickly. I am a human. Can I say you are a human? What is common between both of us? Quickly. What is common between both of us? Eyes, legs, right? So can I say God, God somewhere made a template. God made a template. This template. So God one day casually made a template. Okay, I will make a creature. That creature should have two eyes. Creature should have one nose. Creature should have four legs. Oh my God, four legs. Okay, that creature is nothing but animal. Again, God again chilling someday. I will make a creature with two eyes, one nose, two legs, give conscience, and so on. Oh, this is human. Very good. Now, fine, this is a template. But is my eyes and eyelashes same as yours, Rajkumar? Is my nose same as yours? The answer is no. Hey, right? So this becomes the template. Template is called as class. Template is called as class. Very good. Template is ready. Now, if my eyes, nose, and legs are different from you, then I become Ajay. You became Raj. Someone became Sada. So these are nothing but the object of class human. Object of class human. Right. Object of class human. Similarly here, animal. Two eyes, one nose, four legs. And then again, obviously, someone is dog, someone is lion, someone is tiger. And also in this dog, someone is Labrador, someone is blah, 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 Pomerian and whatnot. Let's take an example of dog only. But let's say there can be dog one, dog two. Dog one, that is Pomerian. Let's say dog two, Labrador. Again, what is this? So these are object of the class animal. Another example, car. Every car will have four wheels. That is a template or a class. But some car is sedan, some car is sports. Yes or no? So these are object of the class car. Clear, Rajkumar? Yes or no? Yes or no? So guys, that would be all for today's class. So guys, how did you like today's class? We will meet in the next class and see other things. So we are going to deep dive into oops, a lot of things we are going to study. But how did you like today's class? Did you guys understood things or it went above the head? Anyone has anything, any suggestions, any comments? Right, right. Okay. So that would be all, guys, for today's class. Thank you, everyone. Right. Tushar says, where is OOPS used in data science? Very good question. Whenever you will make a data pipeline and every project, I would make you guys do in OOPS so that you are very strong in OOPS. Right. Don't worry about that. You will realize that. Right. Sada says, no one teach like you in depth. Thank you, Sada. Thanks a lot, Surbi. Right. Santanu says, need practice, sir. No new things. Don't worry about that. I'm there. Tushar says, give some practice questions. Already practice questions have been provided till functions. So don't worry about that. Iterators, generators, and oops. Again, 50 questions is getting ready. And after tomorrow, on by Monday or Tuesday, you will again receive a 50 questions. Right. Right. Don't worry about that. Rajkumar says, sir, unable to download the notes from portal. Few initial notes you might not be able to download, but after that, are you guys not able to download it? Is it? Is it, guys? Quickly. Right. You must be able to download everything. Just check it out. Alright, guys. So let's meet in the next class. Thank you, everyone. Bye bye.